Now, in this video, we will going to discuss about draw the SFD and BMD for a simply supported beam subjected to a couple at its midspan. So, when you are considering the couple at its midspan, here you have the simply supported beam. Figure shows a simply supported beam AB of length L subjected to a clockwise couple M at its midspan. So, you have the clockwise couple at its midspan. Support reactions. A couple can be balanced only by another couple. Therefore, the reaction at RAV at A and will be in the downward direction, and the reaction at RBB at B will be in the upward direction as shown in the figure, so that they form a couple in the opposite direction. Since the given problem says in the problem at the midspan he has given in the clockwise couple, so obviously it should be in counterclockwise couple. So that means RBB will be acting upwards, then RAV will be acting downwards, then only it will going to form the counterclockwise, so that it will be in equilibrium condition. Now, once you take that, sigma m will be equal to 0. So, taking the moments about the point A, which will be equal to m clockwise couple minus RBV into L will be equal to 0. So, what will going to be the reaction at RBV? The reaction at RBV will be positive m by L. So, therefore, it is acting upwards. As there is no other external load is acting on RAV, so that will be equal to m by L acting downwards. So, minus m by L, so acting downwards. Shear force on the bending moment diagram. Consider a section XX at a distance x from A. So, at section XX at a distance x from A, SF will be equal to minus RAV, which will be equal to minus m by L, because that is the reaction. So, call this equation as 1. The SF is constant at all sections between A and B equals minus m by L. And then when you are considering at section SF at section XX from A between A and C, so BM at the section X, BM at X will be equal to minus RAV into X. So minus n by L into X. Again, equation 2 shows that the bending moment follows the equation of a straight line because the power of X is equal to 1. So when the value of X is equal to 0, then BM at A will be equal to 0. When the value of X is equal to L by 2, BM at C will be equal to minus M by 2. Similarly, now considering a section at distance XX, consider a section XX at a distance x from A between B and C. So when you are considering BM at section X will be equal to minus RAV into X plus M, minus RAV plus, because we have to consider this section also. So minus M by L into X plus M, so that will be equal to equation 3 shows that the bending moment follows according to the equation of straight line. So when the value of X is equal to L by 2 minus M by L into X, so that is into L by 2 plus M, so plus M by 2. So when the value of X is equal to L, substitute that, it becomes BM at B will be equal to 0. So at C, the bending moment rises suddenly from minus M by 2 to plus M by 2 due to the positive couple S. Therefore, when you are considering this, you have at A M by L. So at B also it is M by L. So that is minus M by L. So here when you are considering the section, bending moment at the point A is 0 and the bending moment at the point B is equal to 0, and the bending moment at the point C where you will going to have the value suddenly rises from minus M by 2 to plus M by 2 because this sudden rise due to the couple, clockwise couple at the point at the left hand side. So this is how you will be able to analyze and solve this problem. Thank you.